Welcome to this Sony Vaio revival video, and here I have another eBay purchase. This was my favourite price, very cheap. I think only £8 or £9, so yeah, only 10-12 US dollars, not very much. And this one is going to be a challenge. So whereas some other laptops you have plastic crumbling problems, this one will be metal corrosion problems, as I can see already. Plastic seems okay, except one broken hinge. That's fairly common for a Sony Vaio. So I probably need to explain quite early on in this video why it's half open. So the seller put nice photographs of it open and closed. They certainly didn't oversell it. They said it was only for parts. But the keyboard looked in very good condition, and it does indeed. So when I got the laptop, I went to open it, and the lid is so stiff that this is as far as I dared, and I dared to push it back down. So I think the corrosion has got into the lid, and I'm not going to attempt to open it because the metal is moving a lot. Today's sliding magazine is Logistics Manager September 2023 rather, and with an excellent picture of an aircraft taking off, and I've no idea what aircraft, but it does have winglets, so it's definitely not 1900. Right, let's look around this Sony. So hopefully you can sort of see in there. So we have very modern, I'd say relatively slim design. I think we're talking pre-2000s here, but very slim design. We have small trackpad, keyboard looking in very good condition. We have one sticky key here, it's no surprise, but otherwise very good. Obviously a bit grubby. That is a blanking, there isn't one missing there. So on the lid we have the full size Sony Vaio logo in all very good condition for a used laptop. You can see a few scratches where it's been in and out and travelled, but I think overall with a good scrub that will come up. And I don't think there's anything missing here. We've got these 4 indents, but I think that's part of the pattern. I don't think there was anything in there. Let's carry on, see what we have. So we've got the DC in, which I think is the standard 19.5 volts, something like that. And we've got a very grubby mouse keyboard. I suppose that's PS2, it doesn't say. Very conventional serial, relatively useful VGA. What is this? Oh, that'll be docking station. Definitely don't have a docking station. Looks like it might have infrared. Okay, let's look at this one. And here we have conventional printer. We do have USB, and one of the reasons I wanted this, we've got a video out. So I like an old laptop with a composite video out. That's always good for a bit of experimenting. Now tilting it up, we can see more evidence of the corrosion. I can see some corrosion on the back there. Yeah, that's quite ingrained, maybe past the plating. It's not totally gone. I like the way those open down, but you wouldn't want to lean the laptop on them though. Interesting. And the sockets seem okay. The pins are dull, but I wouldn't say absolutely corroded. So it's like there's some level of damp, but I don't think it's actually got wet and sat in water, thank goodness. So on the corner we can see the hinges just plain rusty. I'll call the rust police for that. Obviously we've got one piece missing, so that's a shame, but not the end of the world. It looks like a small piece. Maybe one day when I get into design and ordering 3D printed parts, that might be a nice candidate. Headphones and a strange looking socket I don't recognise. I have to look that up. Sony thing. We've got microphone and What is that? Surely that's not video in. No, that's just line in, I think. Right, so we got video out, but and I think that must be line in. But we've got microphone, so nice. 2 levels of input, very nice. Down the side we've got, I think, hard drive and battery. Very sleek along the front, no interruptions. And then on the other side we have PCM CIA, and this is a nice design. So these controls, they fold around like that. So you pull it out, push it in, and we have one blanking with a bit of life there by the look of it. Well, a bit of former life. So that is the Sony Vaio. Let's look at the model. Let's confirm the model. Let me confirm the model name. Model name is PCG, I think that is, 747. And quite simply, maybe that's a flash chip. Maybe BIOS or something. Who knows? And the second cover, which I think is memory. Wow, look at that. It's Christmas, right, 64 meg SIM. That's pretty good. Remember, I only paid a few pounds for this, virtually nothing. Maybe they don't work, but they, see, these look okay. Let me take the one out that doesn't have any markings. So I don't see much corrosion on those. What do you think? That is Samsung stuff. It's interesting, it's all different, but I imagine a machine like this is quite, would have been quite expensive, and you would upgrade it through its life. So I think the next stage is I'd like to power it up. Let's have a go, see what happens, and if it works. It was, of course, sold as for parts. I'm going to take the battery out, I think, before I try and power it out, just to reduce the complexity. Now this is quite a tricky operation. You have to move it out the way like that. There we go. And lift the battery out. So, a little bit of an awkward operation. Let's look at the battery. So what do we have? Do we have the voltage? 14.8 volts, 3000 milliamp hours. So really of its time. Oh, it is lithium ion. We're not talking NiCads here, interestingly. I've got this Sony power supply. It's actually from one of my own Vaios that I bought. 19.5 volts there. They were standardized for a long time. So, right, let's see. Are we going to be lucky? Plug it in there, DC in. Fits nicely. Okay, I hope you can sort of see that. Right, where is the power button? I think it's there. So let me see. I can see the LEDs and nothing at all. I can't hear any whirring, I can't hear anything. So that's a shame. Nice laptop, no activity at all. We are plugged in and working. So often the first stage in trying to power a laptop up is to remove as many components that might be impeding the startup. Although we certainly do have a clue in the state of that power socket. You can see some corrosion there. So I think the CD-ROM, that's quite a large item that can come out. I've got a slider here, so is it a slider? Yes, it is. That's fantastic. Any clues Ah, this is good. We've got November 1998. Now, this is dirty, but no corrosion, so what a random mix of corroded and not corroded. See, that's just dirt, I think. Tiny bit of mold, maybe. Let's see if there's anything in here. And we're going to ping open. Ooh, CD in there. Shania Twain, Greatest Hits. Oh, there you go. 2004. What condition is that in? It's a bit scratched. I think this laptop's starting to cover its price. Let's look at the hard drive. Now, I have removed this before. I started the recording because I wanted to firstly see if I could get an image. It's not always that easy to get hold of Sony images and things like that, but I think this is very gone. We've got a date of 1998-11. I've got older hard drives that work than that, but I think this hard drive has gone. And in particular, I noticed the screws here are corroded, although the hard drive looks okay. And I had to drill one out to remove it. And I don't know if you can hear this, but if I twist it, I don't think that's very healthy. The laptop's certainly a bit lighter. And we have nothing at all. So let's make a start on disassembly of this laptop. Sony helps us with the arrows pointing towards the screws that need to be undone. So as I mentioned, I did take the hard drive out of its caddy and one screw needed to be drilled out. So it'll be interesting to see if any of these are corroded. The more I can see, obviously. So that's it for now. So does any other part that's come off? I wonder if I can remove this battery cover. Yes, there we go. That comes off. Got screws for the screen, and bearing in mind the screen is a bit frozen in the hinge. Let's try those. Let me try this bigger screwdriver. No, that's too big. This one maybe. No, that's too small. What about the other side? Right, these are going to be difficult. Time to bring in a screwdriver set. I think we need to try lots of different bits to see which one is going to fit. Okay. So it needs to be quite small. I've got one broken one here, I don't remember that. Oh, this is looking very bad. It's a very small screw. I think all the bits in here are going to be too big. Let me try this one, which I can't even get at. I actually need some tools to get at my tools. That has some purchase on the screw. Yes, brilliant. Look at that. Right, let's not take it all the way out. And do the other one. And this one looks better. magnetic, so I can't do that. Right. Okay, that's good. Right, they are loose, so let me put the laptop down. And undo them. There we go. Ooh, that's bad. That feels really bad. Let me support it a bit. That is, something is trying to undo, and then it suddenly came loose and the screw has broken. Oh no, what a nightmare. Okay, well, if it was going to happen, it was going to happen, and this is the better screw. Wow, look at that, that's probably broken. It seems unlikely this side isn't going to break. I'm wondering if I need some WD-40. No, this side is fine. So that looks like some sort of pressing or rivet. That's not going to come apart. I can see this wants to pull forward. Ah. Pulling this forward, it has released it at the back. The other side is not released. I see we've got clips here, so I just need to get it over those clips. So I'll push the bottom of the keyboard. There we go. I think the next stage is to use maybe WD-40 or something similar on these, on the screen, and open the screen back maybe. Let me just drop that in there. Right. So is that going to be enough to free up the lid? That sounds really bad. There we go. Maybe the lid needs to go. Oh, the lid is a bit looser now. So does this pop up maybe? Everything seems to half pop up. That half pop up. I can see a clip here holding this on. That is definitely stuck that end. Maybe that is a cover. Wow, it is. That is actually a screw hole. And it had plastic over it, implying this has never been out before. And here we go. Let's see, so there was a screw there. Oh, that's very broken. And there doesn't seem to be a screw there. Interesting. Right. So now I can take the keyboard up and away. I'll remove the keyboard, I think. which has got very tight little ribbon cables on it. I wonder if this keyboard works. Not really Dell serviceability, is it? There we go. My keyboard is out. So now I can remove the trackpad connector from this end. And all the tape come away nicely. It has ripped, not surprising. Okay. Right, so those are those components. I think we can set this to one side for the time being, as it's only the trackpad. Lots of corrosion on this connector. So that goes up. Okay, that removes from there. Oh, look at that. Oh, that's the microphone. BIOS battery here. And we're looking on that. It is Vata, but I think we're okay. Doesn't want to come out. There we go. And again, this is very shiny, so real mix of untouched and then corroded. Right, so I've unscrewed that, but that ain't shifting. What holds that in? Ooh, that just about came undone, and that did that. Okay, that might have survived. So I'm going to take the laptop downstairs and drill this out. Not quite there yet. It does move about. It's not quite going over the screw bit, so a bit more drilling. Right, so we're getting there. It's a bit of a mess now. And there we go. It's clearing the screw. Back at the workbench, we've drilled the remains of that screw out, which came from that foot. It broke off. I've drilled enough now to lift the screen out on that side. The screw the other side wasn't stuck, so I need to lift that out without the plastic coming with it, which it wants to do. Oh no, does the plastic want to come with it? Please, Mr. Plastic, don't come with it, you'll break. Why is the plastic coming with it? Okay, so the screen is separated. I've broken this off. Yeah, that is all gone. That's a shame. I think this painfully delicate bit of plastic has actually survived quite well. So how did they get that through there? Did they make that? That's quite annoying, Sony, that you've done that. In fact, this small audio board can be lifted off. Something fell off. What was that? I have no idea where that came from. Right. So I think I'd like to progress lifting the motherboard out and testing the motherboard outside of the case. Oh wow, look at that. I didn't realise that was going to happen. This one's okay. That's okay. No, that's whatever's screwed into is just bending down. Okay, that's a problem. Okay, that went a bit more suddenly than I expected, so never mind. What carnage do I cause with the drill? I think a lot. It's lifting up. Should have removed the fan in the first place, really. Except that the wire is fed around somewhere. Very difficult. Big piece. Right. So that is off. I've caused some damage with the drill. That's okay. I could tidy that up. So the fan blows on a bit of aluminium. Okay, and there is the remains of the screw. Screw is out now. That didn't sound good. Oh, I see, there's two connections that end. Sony, that was a cruel thing to do, to put that screw underneath. It really is as if there's another screw. Where can there be another screw? I think this wants to pop out. There is another screw. There has to be another screw. There we go. I'm not sure how that happened, but maybe that was something to do with the connectors being through there, but it just popped out. So how is this looking? Does the PCM CIA come off? It does. But the next stage probably is to try and test this standalone, because if it doesn't work, if it is too far gone, there's not much point with the rest of the laptop. Yeah, there is green around here. So the first steps are to measure with the voltmeter if that's getting that. We do have the VGA out, so it might be time to fire up the VGA monitor. And the other worry is the state of it around here. Though it's not a disaster. I don't actually see much damage to the PCB. And I do wonder if it's just the socket that's failed. So we should probably power up and measure voltages here and at the switch. So this is looking, yeah, unfortunately there is corrosion around there. That is a bit bad. And maybe that coil. So I've done some basic cleaning of this board, and it's not in brilliant shape, but some improvements have been made. So just to wipe down with cleaning solvent under here has actually wiped a lot of the corrosion, so I think it was maybe just watermarks. Let me plug it in, let's see if we get any. I have spent a lot of time trying to brush away any swarf from all the drilling of the screws. Okay, let's measure the voltages. Don't know which is plus or minus. We get some voltages. Interestingly, we don't get 19 volts. We do, 19.5 volts, right, so that is making it to there. So the socket is okay, which I did wonder about. Did just a light clean inside the socket. So the next stage is this switch 2. So we've got, let's figure out what is ground. In fact, normally the metal body of the backplane is ground, so okay, so that is that. So I think the next stage is to measure each of the switch contacts. Let me light that side of the board a bit better. Okay, so one switch contact we have 5 volts. Well, there's lots of good news. That means a 5 volt power supply is working. So the next stage has to be with the CPU plugged back in and the screen. Will it come to life? The screen seems to take power through this connector as well. This is quite badly corroded. I can't see where the power goes. There we go. And where on earth is the power switch gone? Oh, Sony, what have you done? I'm going to have to put the plastic power switch in because it's hidden by the CPU. What a bizarre design. Wow, couldn't be more difficult, really. Now I've got to find the power socket again. And it does seem completely dead. So where did we get with our Sony Vaio motherboard? Well, I'd worked through that there is 5 volts working, and I think that was the 5 volt regulator. So when the Sony 19 volt power supply was plugged in, we were getting 5 volts and the controller was getting VCC. So this chip, the SMSC FDC37N 958 chip, has a really good datasheet available on the internet, and this is almost like the controller for the PC. It does a lot of tasks. So scrolling through its datasheet, we have floppy controller. We've got a parallel port interface, serial port interface, and also it's got a microcontroller that effectively handles the power and so on. So on this board, I found that the actual power controller chip for the main 5 volts and 3.3 volts goes via a 1K resistor to pin 147 on here. Now let me look up page 8 of its data sheet, and pin 147, you can see the tiny markings where you might be able to see how close can I go. Yeah, pin 1 to 52 actually silk screened 53. So if we go to pin 147 and look on the data sheet, that is I think that's a GPIO 12. So it's one of those pins, so general purpose input output. So this chip needs to signal to here, and the 3 and 5 main 5 volt controllers are parallel together. So when I was operating the power switch, this chip for some reason was deciding not to raise that. So the next step was to find out what the power switch did. And here we have the power switch, and I discovered that we've got 5 volts here. I don't think there's anything connected here. And this one appeared to be connected via 10K to somewhere. I'm not sure, maybe ground. So that's normally maybe pulled up, and then it either grounds or sends it to 5 volts. So that gave me some clues. I tried to buzz out with the multimeter just touching around, and maybe my multimeter isn't too responsive on its continuity. But the 10K was a clue, so I was looking for a 103 resistor. So I found that 103 resistor, believe it or not, to be here. I don't think the phone will be able to see that, no. And that did have 103. I was looking under some lens goggles to see that. And that's attached to, I think, this chip, which is a dual Schmidt trigger. So that's cleaning up the signals from this, because of course this is not a power switch, it's a button that tells the controller, because it's an on-off switch and to force it to close down, etc. So the output of the Schmidt triggered signal from there then went into in 3, which I think is pin 151. So I actually buzzed that out to here, and I could test that going between 0 and 5 volts on that in 3 pin. So the question is, why wasn't that firing the output? I'm looking at the data sheet. This chip has VCC1, which I think is constant 5 volts from the constant 5 volt regulator, which I think is there. So a tiny draw, effectively the standby, and this pin, which is pin 105, I think, 105 maybe, that's called VCC1 power good. And in the data sheet it does say that that's pulled high, but what I was finding was that when it was powered, that was being pulled very low. There was clearly a transistor MOSFET, maybe some output circuit was pulling that low, and this microcontroller won't start until that pin goes high. And I was thinking that was maybe some power delay, some power conditioner, and I spent a lot of trying to buzz out that, and I never found where that came from. I even thought about trying to lift it and let it float high, but I didn't want to damage it. So this is what I discovered. Basically, I had removed the ROM flash during my buzzing out, and I think this gets a flash memory ready. But I have buzzed out that VCC power good to here, and I can't find any connection. What I discovered is that when the flash is plugged in, this gets its VCC power good, and then this goes on to command this by the power chip. So with the board here, I've got the LEDs and the monitor now plugged in. I'm going to try powering it up with its own monitor attached. So mains power on. We try power switch to the LEDs. Still going to light up. Let's look at the monitor. The monitor is sadly dark. Cold and dark. I have a little bit of heat. I can feel a bit of heat on the CPU. So upstairs I've just seen the card actually start up with some LEDs. So I brought it down to the VGA monitor. Just in case. It says no input signal. Power supply is on. So if I turn it on, okay, we have an LED, but surely the output is too broken to have a picture. And in fact, my other Sony machine never gave a VGA as its primary output when booting. But looking at the damage now, that is LED is still on. That will stay on for a little while and turn on off by itself. How close can I go with the damage? That close. Can I zoom in? Now this is around these connectors, so that's the VGA. That is the main area of damage. You can see there's a lot of corrosion around that connector and also around a lot of the components there. And in fact, if I can show this chip is actually completely lifted off one side. Now there are two chips like that, one there and one there, so the wiring is fairly obvious, goes to these two devices. I don't know what they are, maybe they're, I don't know, sync drivers, something like that, who knows. And the other option is, does the docking port, there we go, the LED has turned off now. Does the docking port have VGA output? I could buzz those on. But I have confirmed that there are problems with these, and let me try and set up the meter to demonstrate that. So I've got the meter connected to one leg of this capacitor just to connect inside the pin, and I'm touching the meter on a via that's connected to that. And if I push down on the pin, then the pin pushes down on the board. So that particular pin has lifted and lost contact. And I think it's the same for some of the connectors for the actual internal monitor. Although we know some of these are working because the speakers pop if I plug the monitor in. So I think there's no way forward. We've got both video outputs compromised. Let me see. Yeah, there are the corroded legs, and I think those are in the same condition. So really, there's no way forward to progress this other than removing those connectors. Pretty specialist work I don't have. And of course, there's lots of other problems. There's that lifted IC, and that's not to mention the other corrosion that has gone on vias around here. But I think that's how you'd progress this board. You need to be confident at least that you're getting VGA out. I think the probability of finding docking connector is going to be very low. So that is our Sony Vaio mainboard with its corrosion issues. So maybe one for the future after a lot of investment in surface mount removal tools, I think, for this very delicate board. But I feel it wants to come to life one day. But maybe the PCM CIA socket will never work with the particular corrosion around its controller chip on the other side.